everyone on YouTube, GeoSnowRate here. So in today's video we have the part 2 of how to build an iOS 11 jailbreak from scratch. Now in the first video that you can find in this playlist in here, we talked about how to create a project and how to include QiLin, which is a jailbreak toolkit that's going to save us big time when we're building the post-exploitation part. But now in this video we're going to get a little bit more physical with this iOS kernel, and we have to touch the kernel in all the right places. Not really, we have to get the kernel base, and the kernel base is actually much more harder to get than you would expect. And I'm going to tell you exactly how we're going to do that. We're going to use open source code from both some exploit in the past and from some iOS 11.1.2 jailbreak, but that's fine because it's open source. But anyways, if you didn't see the first video, go ahead and see it right now before you see this one, because this one wouldn't make any sense if you missed the first one. Now, if you're not subscribed to the channel, go ahead and subscribe right now and activate the bell icon to make sure you don't miss any future videos. Okay, let's start into this thing. So we're going to open the project that we have in here, but before we do that, we're going to have to replace some files. Why? Well, I have created in here a copy of the exploit.c and exploit.h, which is pretty much the multipath exploit we're going to use for the iOS 11.2 all the way up to iOS 11.3.1, but this one also contains some big modifications, and the modifications are some functions from the async wake. Now, the async wake is pretty much an older exploit for the iOS 11.1.2, if I remember well. Yes, iOS 11.1.2 was the last one supported by this one, so it's a previous exploit, but this one also contains some very important files, and I'm going to show you what I'm talking about. When you download it in here and you open it, it has these files in here. As you can see in here, aside from the exploit, we get a few files called kutils.c with its header, we get kmem.c and its header, and findport.c. Now these are very useful kernel utilities that have been used in many jailbreaks, not only based on the async wake. In fact, I think even Electra for iOS 11.3.1 still uses some of these functions somewhere deep in the code base, but don't quote me on that. Anyways, these kernel utilities have been used a lot, and we're going to use them as well because they save us big time, and we have to use them because the function that we're going to use from this iOS 11.1.2 jailbreak, which is going to help us to pretty much dump the kernel base, is heavily based on those kernel utilities from async wake, so we have to add them. But adding them is not an easy task because I decided to add them directly into the exploit.c from the multipath, and so it would have taken too much to add them manually in a video. So I decided to release these files in here that you're going to replace in your project, and this contains all the async wake stuff that you need in order to be able to call the next features we're going to add in this video. So what I have to do is to download this. We're going to download it and replace it together, and this one here should contain the async wake kernel utilities that will of course give you all the abilities you need. So we're going to extract it in here and get our project, which in this case should be multipath, which is this one in here in my case, the one that we worked in the first video on. And in here we're going to pretty much replace some stuff. So we go into the project we downloaded and replace the exploit itself. So do this and replace. There we go. Now that we replaced it, we should be able to do the next step. So what we want to do now is to open the multipath in here, and there we go. Now we're going to have some errors, but do not worry, we're going to have to fix them. And the first error is the fact that there are two Go functions available. So if you go ahead in here and open the linker error, you can see that it tells us that we have the enable bitcode on, and it's not supported by QiLin. So we're going to have to go here to build settings, search for code, and look for bitcode, and yeah, it's this one in here. And instead of setting it to yes, we're going to set it to no, and that will fix one of the errors. Now if you press play, you're going to get another error, and as you can see, it's still a linker error. And this one pretty much tells us that we have a duplicate symbol, and the symbol is pretty much Go. Well, the error itself is not very clear if you're a beginner, but I'm going to tell you what the problem is. It tells us that we have the same function called Go both into the exploit file, the exploit.c, which gets translated in exploit.o for object, and in QiLin, which is QiLin.o or QiLin object. So we can't have the same name for both functions. Okay, so let's go ahead in here on the exploit, so exploit.c, and we're going to modify that function to no longer be the same as the QiLin one. So we're going to search for Go with Control F, and as you can see, we found it, and it's called Go in here. We're going to replace it with exploit like this, And instead of void, we have to pretty much make it to export the task for PID0. But let me explain why. So if you go ahead here on QiLin.h, these are all the functions that QiLin can support, and those are exported from the QiLin.o. So you can see that we have an initializing function. In fact, we have 3 of them, but we're going to use this one in here, which returns an integer, 0 or another number. And in here we see that it takes 2 arguments. The first one is task for PID0, and the second one is the kernel base. For the moment, in our jailbreak, we have neither of them. So we have to get them in order to be able to initialize QiLin, and therefore to be able to run any of these features in here that we need in post-exploitation, unless we want to build them manually, which we don't. So in order to be able to initialize QiLin, at first we need to get the task for PID0. You're going to ask me how the hell we get that. Well, that's pretty much the purpose of the multipath exploit. It pretty much pounds the kernel, and then it gives you the task for PID0. The problem is that it doesn't export it by default, so we're going to have to modify a little bit the exploit in here to change it from void, which means literally nothing, into a Mac port T, which is going to be pretty much the task for PID0 or the kernel task port. So let me show you. We're going to do Mac port T. So now this function in here will return a Mac port T data type. So we're going to go ahead on the end of this function in here, and in here you can see that it says printf done. This is everything that it does. It doesn't return anything. So we're going to have to pretty much add a new line with return, and we should be able to detect what is the name of the variable that holds the kernel task port. So let's do Control F and search for tfp0, which stands for task for PID0. Let's see where it appears and how is the variable named. So we have tfp0 in there, and we also have, let me see, new tfp0. So this is what we have to pretty much export at the end. So we're going to close the search, and we're going to go back in here at the end, and we're going to pretty much export the variable out. So let me do that. Return this one in here and add a semicolon, and at this point this function, when it finishes and exploits the kernel, it should return the task port. Now normally this patch has to be applied, and is being applied by the exploit somehow, and let me explain you why. Well, the kernel itself runs as a process on the system, and its process ID 0. That's why the patch is called task for PID0, because we literally get the task port of the process ID, or PID 0, which is the kernel. Now normally on iOS, with the correct entitlements, you should be able to get the task port of another running process, and therefore be able to control its virtual memory, you know, to read and write to it. Of course you can do that, and there's a function for that. Unfortunately, that function has checks to prevent you from getting the task port of the kernel, which is of course obvious, because otherwise any process with that entitlement would be able to pretty much pound the kernel given enough privileges. And that's the problem. So normally we would have to patch the task for P function in order to return the task port of the kernel, but that is already done by the exploit itself. We just have to return it to QiLin. So we're going to get this in here with return new tfp0. That's the thing with this task for PID0. That's why we need it. So as you can see now, we have a couple errors in here that we have to address, and these errors are pretty much saying, quote, non-void function exploit should return a value. And that's true, because as you can see, we have in here returns, but no numbers and no values. Unfortunately, that only works if the function is void. If it's not void, it has to return something. So in this case, since this one is an error, I'm going to return -1 in case we hit it. The same thing goes for this one, since this one is an error as well. And this one is again an error with unable to find kernel task map. And then again, this one in here is also an error, so we're going to say -1. Now, for those of you who do not know, if you return 0, pretty much it means that the program ran completely or successfully. If you return any other number or a negative number, it means that something went wrong, and depending on number, you can handle the error case. But in our case, we just want to silence that warning. So then we have a linker error in here. So let's see what the problem is. But first I'm going to press compile, and definitely it did go. So we no longer have that error. It was the remaining of the QiLin problem. So now our function is able to return the task for PID0, or the task port of the kernel, which is something very, very useful. Now we have to create a new file in here, which is going to be called post-exploitation. It's going to be a C file, and I'm going to call it post-exploitation.c. Press next in here and press create, and there we go. So here we're going to do all the QiLin related stuff. including the initialization of QiLin that we're going to have to do. But for the moment, we still can't do the initialization, because if you take a look in here on the QiLin.h, we do have the first requirement, which is a Mach port T TFP0, or the task port of the kernel, but we don't have the kernel base, which is required. Now, in order to get the kernel base, we need to play a little bit with async wake, and we have to play a little bit with a function from this public jailbreak in here for iOS 11.1.2, which is an older jailbreak by Coalfire-Research. He has a function in here that uses the async wake, kmem and kutils, and we can use it in our jailbreak as well. So we're going to search for it, and I actually marked it so you can see it, and I'm going to try to explain how it works. So let me find it first. It's this one in here, and we're going to have to take it. So I'm going to take the function in here, and we're going to go ahead and paste it in our exploit file in here, so exploit.c, and we're going to paste it at the end after the exploit function, so in here. And let me try to explain what this does, but first let's clean it up a bit, because some things in here are not right. We're going to have to remove this comment in here since it uses a different method. And as you can see, this function takes a kernel base of type uint64t and the task for PID0, or the kernel task port. We're going to have to do some modifications around here. So we're going to have to remove this argument in here since we're not going to use it. And since we do that, we're going to also have to remove this bit in here, which uses that, and this bit in here, which again we don't need. So we're going to clean up the spaces in here, and this function in here should give us the kernel base. But what I'm going to do is to credit the original author. So I'm going to go ahead in here and take the project like this, copy it, and say in a comment, this function was taken from here. Okay, so that we properly credit the original project, since I didn't write it, so we have to credit it properly. Alright, but let me explain how it finds the kernel base. Now, the kernel itself is a Mach-O executable file, and this means that it follows the same Mach-O structure. So in this case, it should have a magic number. On 64-bit, that one is 0x feed FACF, and on 32-bit is 0x feed face. Now, these magic numbers are very useful because it's a very good way to check whether the application, the program, the file, the binary, whatever you want to call it, it's really a 64-bit or 32-bit Mach-O file, or it's a completely different thing. We're going to give this function access to the kernel task port so it can read the virtual memory of the kernel, and we're going to iterate through that memory until we find the magic number, which is, as I said, 0x feed FACF for the 64-bit, and then we know that we found the kernel base. That's how it works. Okay, so now that we have this in here, we're going to rename it from dump kernel to get kernel base, like this, and we're going to have to select all these in here and copy it and put it in the exploit.h so that we can pretty much export the function. Then we're going to also have to modify this one in here. Since it's no longer called go, it's called exploit, and we're going to also change the void to Mach port T, because we also changed that in the exploit.c. So now we should be able to use this in here. Now we're going to go here on the post-exploitation.c, and we're going to include exploit.c. In this case, we're going to be able to use the functions we talked about. So the first thing to do is to create a new function that will handle the initialization of QiLin. So what I'm going to do is to pretty much say int init QiLin now, and we're going to pretty much add what we need in here. So I'm going to take this function and I'm going to put it in the header file in here. So we're going to do this, and we're going to add void to it in here because it doesn't take any arguments. And of course, we're going to go back in here. And here, what we need to do is to create a few variables. The first one is going to be of Mach port T. And the Mach port T is necessary because we're going to create a new variable called TFP0, which will hold the task port for the kernel. Then we're going to create another one of type uint64t, and this one is going to contain the kernel base. So it's going to be an address. So kern base, like this. And these will be assigned, of course, in a few seconds, but we're going to return 0 in here for the moment to silence that warning. and of course we have to deal with the rest of the stuff. So for the task for PID 0, we need to call, of course, the exploit in order to get task for PID 0. So we're going to say equal with exploit, and the exploit function will be called, and after that we're going to get our task port for the kernel. Then the kernel base will be, of course, get kernel base in here, and this one takes an argument, and the argument is the previously taken TFP0. That's why we do it in this order, because we have to get task for PID 0 first before we can get the kernel base. And now we're able to call that function from the QiLin.h, which is this one in here, init QiLin, which takes two arguments, the kernel base and the task for PID 0. So we're going to copy its name from here, and we're going to go ahead into the postexploitation.c, do this, and of course we're going to call it with tfp0, comma, kern base, like this. So in this case we should be able to do this. Okay, let's press the play button and see how many errors we get. It says that implicit declaration of function init QiLin is invalid, and the reason for that is that we didn't include the QiLin header. So QiLin.h in here, and we should be able to do it now. Let's see if we get any errors. Okay, so invalid declaration of function go. And yes, the problem is, of course, that if we go ahead in here on appdelegate.m, by default, this exploit proof of concept had this go function, which was the exploit in the application did finish launching with options, which means that when the application started, the exploit ran automatically. We don't want that. We want our exploit to be controllable, and we want to be able to run the exploit only if we press a specific button. So we're going to have to remove this bit in here. And of course, we're going to have to remove this including here as well, since it's no longer necessary. And then we're going to go here to main.storyboard. Here we're going to have to create a new button. So button, in order to trigger the exploit. Of course, we're going to fiddle more with the design in a future video, but for the moment we just want to test if the kernel base is fetched correctly, if the TFP0 is exported correctly, and if QiLin is pretty much starting correctly. Otherwise, we wouldn't be able to do anything down the road. So we're going to say jailbreak in here, and of course we're going to have to press the circles to open the split view, and here in the viewcontroller.m we're going to create a new action. So we drag with the right click of the mouse and create a new action in here called init jailbreak. So this one in here will pretty much start everything. So we press in here to close the split screen, and we go ahead in here in the viewcontroller.m, and in here we're going to need to include the header for the post-exploitation. So post-exploitation, like this, and there we go. Now we're going to be able to call that function, and the function is init QiLin now. So this is going to be in here. Let's do a sanity check. So if init QiLin now equals 0, or if the function runs properly, we're going to do this in here. Say printf QiLin was initialized, like this. And we're going to add the semicolon, and if it's not, if it says anything else, we're going to pretty much say that it failed. We have to be able to test if everything in here works fine. So we're going to add the new line in here like that, and the semicolon. So in this case, what we're going to do is to pretty much go back in here in the post-exploitation and do something. And this is going to be if this function call in here equals to 0, then we're going to pretty much do this. So we're going to remove this and return 0. So what we do in here is pretty much, if this function call is complete and works fine and QiLin is initialized, we're going to return 0. If not, and we get another number in here other than 0, something went wrong down the road, and we're also going to return something else. So else, we're going to return -1, which means that there's an error. So now we have some sanity checks down the road. Let's connect the device and see exactly what we need to fix next. So I'm going to press in here, apparently nothing, we're able to do a test. So we're going to see here in the console exactly what's going on and whether our program works. Now what we should expect? Well, we should expect the QiLin to work properly unless it restarts due to the exploit, and I'm going to press jailbreak now. So the exploit started, as you can see here. This is the multipath exploit, and we're going to wait for it to get all the privileges, and then we should see that QiLin pretty much started. Of course, that's granted we do not restart due to a problem. Okay, so everything is in here, And there we go. As you can see, QiLin was successfully initialized. Now what this means two things. At first, we got completely fine the kernel base and is correct. And then of course we got the task group PAD0 properly. Because as you can see, after the exploit finished, we got the kernel base in here. And since it has the FFFFFFFF in here, it means that it's a kernel pointer. And then of course we successfully started QiLin, and as you can see, it gives me the information about the kernel and the device, which is an iPod Touch 6th generation. So yeah, QiLin was successfully initialized. That's pretty much it for this video, because this video is getting ridiculously long. In the next one, we'll continue adding the post-exploitation part. Thank you for watching, guys. I really hope you enjoyed this video. And if you do not forget to give it a like and subscribe to the channel. Peace out.